today we are going to discuss about quadratic equation and its basic. Let us start with polynomial equation of degree n. A0 x to the power n plus a1 x to the power n minus 1 dot 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 plus a n x to the power 0 is equals to 0. This is the polynomial equation in degree n. If we put n is equals to 2 here, we are getting a0 x square plus a1 x plus a2 is equals to 0. This is the polynomial equation in degree 2. Degree is the highest power of variable in any equation. Okay, the coefficient with highest power of variable is known as the leading coefficient. Here it is a0. A0 is the leading coefficient. Okay, equation, so that we can easily now standardize this equation into the form of standard quadratic equation. Ax square plus bx plus c is equals to 0. This is the standard form of quadratic equation that we are familiar with. Okay, sum of the roots of quadratic equation we know is b by a minus b upon a. Product of the root is c upon a. Okay, now we all know that these are the product of the root and sum of the root, but we don't know how it is derived. So let us derive these two forms: sum of equations, sum of the roots and product of the roots. Okay, so we have to first derive the quadratic formula. Quadratic formula. Ax square plus bx plus c is equals to 0. X square plus b upon ax plus c upon a is equals to 0. X square plus b upon ax minus b square by 4a square plus b square by 4a square plus c upon a is equals to 0. And we are factorizing this quadratic equation with the help of completing the square method. It is one of the method to factorize the quadratic equation. Okay, x plus b upon 2a whole square plus 4ac minus b square by 2a is equals to 0. Here we are getting x is equals to minus b plus minus under root of b square minus 4ac upon 2a. Okay, so we are getting here x is equals to minus b plus minus under root b square minus 4ac. So here are two roots we are getting. One is with positive sign and another with negative sign. Let us see, one root is as alpha and another root is beta. Alpha and beta. Alpha is equals to minus b plus under root of b square minus 4ac upon 2a minus b plus minus b minus under root b square minus 4ac upon 2a. If we are adding these two roots, alpha plus beta, we are getting minus b upon a. And we are going to multiply these two roots. We are getting from here alpha plus beta is equals to c upon a. So these roots are come from here. Okay, and this expression is used to find the roots of the quadratic equation, and it is generally known as quadratic formula. Okay, now consider the quadratic formula. The quadratic formula, from quadratic formula we have the two roots, that is x is equals to minus b plus minus under root b square minus 4ac upon 2a. Okay, from this formula we have find that one root is with positive sign and another root with negative sign. So now let us consider that we have to write a quadratic equation using the sum of roots and the product of the roots. So x, it can be written as x square minus sum of the root times x plus product of the root is equals to 0, or x square minus alpha plus beta x plus alpha beta is equals to 0. Basically, alpha and beta are the root of the quadratic equation, standard quadratic equation. Ax square plus bx plus c is equals to 0 has two root. one is alpha and other is beta. So this quadratic equation can be written as a form of this quadratic equation, having the alpha beta as its roots. Okay, so we can write quadratic equation in the form of sum of its roots and productive roots if we have given two roots, alpha and beta. Okay, now again let us consider that from quadratic equation we have got two roots, and these can be written as x is equals to minus b plus minus under root of b square minus 4ac upon 2a. Okay, in this expression, this b square minus 4ac is known as the discriminant d. It can be written as the discriminant. Okay, so we can determine the nature of root using the value of d. Okay, so how to determine the nature of roots? Nature of roots. Okay, so our main purpose is to determine the nature of roots. So we can say if a x square plus bx plus c is equals to 0, this is the general quadratic equation. In this, a is the leading coefficient. If a is greater than 0 and d is greater than 0, it means that the quadratic equation has real and distinct root. Real and distinct roots. Okay. Now let us further consider if this d is perfect square or if not perfect square. If this d, if it is perfect square, then roots are rational and unequal. Okay, and if this d, it is not perfect square, if it is not a perfect square, then the roots are irrational number, and we know that these irrational roots are occurring conjugate pair, and we know that irrational roots occurs in conjugate pairs. If one root is 2 plus root 3, another root is 2 minus root 3. This is alpha, then it is beta. Okay, this is an example. Okay, this is the conjugate pairs. And if this quadratic equation, now this is the first case, now consider second case. If d is equals to 0, if d is equals to 0, it means that roots are equal. Okay, if d is equals to 0 and a greater than 0, then roots are equal. Okay, and third is if d less than 0, a greater than 0, it means roots are imaginary number. And we know imaginary roots occur in conjugate pairs. Okay, example, if one root is 2 minus iota 3, so other root is, if it is alpha, then beta is 2 plus iota 3. This is beta. Okay, they occur in conjugate pair. So this is all about discriminant. Okay, it is for a greater than 0. Similar, it is for a less than 0. If a is less than 0, then b is greater than 0. They are in distinct roots. The thing only change is that the graph of parabola. If a is greater than 0, parabola open upwards, parabola mouth open upward. If a is less than 0, parabola's mouth open downward. Okay, similar cases are with a less than 0. Okay. Now, for solving the quadratic equation in a more extreme and extremely easiest way, I will tell you some point, and I will remind you these point as footnotes. Please write it down. These are very useful for any competitive examinations. Okay, so I will explain you. May I write it as footnotes. First footnote is, we have a quadratic equation, general form. We can write general form of quadratic equation is ax square plus bx plus c is equals to 0. This is the general form of quadratic equation. Okay, in this quadratic equation, if a is greater than 0, we consider this a is greater than 0 and c is equals to 0. If c is equals to 0, it means that we know that product of the root is c by a, and it's come out to be 0. If the product of the root is 0 and it come out to be 0, and there are two roots, the two numbers product is 0 when one number is 0. Okay, this is obvious. So one root of this quadratic equation is 0. One root of this quadratic equation is 0. Okay, now another point is, if a greater than 0 and b is equals to 0. B equals to 0 means sum of root is equals to minus b by a, and it come out to be 0. It means that roots are inverse of each other. This simply implies that roots are inverse of each other. Means the roots are equal in magnitude but opposite in size. Okay. Now third point is, if leading coefficient a is equals to 0, then what happens? If a is equals to 0, this equation become bx plus c is equals to 0. This is the linear equation. In which I have considered b is greater than 0, c is greater than 0. So I can draw its graph simply on a graph paper. It's come out to be like that. This is minus c upon b, and this it touches the y-axis somewhere. Okay, this is the minus c upon b comma 0, and this extends to infinity. It means that it cuts x-axis at minus c upon b. So its one root is minus c upon b and another root is infinity. So if a is equals to 0, it means roots of quadratic equation. It means one of root of quadratic equation tends to 0. Okay, we can say that. Okay, fourth foot point. Now we consider with moving on fourth foot point. Okay, fourth one is, if coefficient of quadratic equation is in cyclic order, then its one root is always 1. Example: p square minus q square x square plus q square minus r square x plus r square minus p square is equals to 0. If we put x is equals to 1, then p square minus q square 1 square plus q square minus r square 1 plus r square minus p square is equals to 0. It means that p get cancel out, r is get cancel out here, q is get cancel out here. LHS is equals to RHS. Both are equal, hence its root is always 1. It is satisfied. And the sixth point is, if root of quadratic equation are inverse of each other. each other, then ax square plus bx plus c is equals to 0. Have one root is alpha and the root is minus alpha, 1 by alpha. So product of root is 1. Okay, product of root is 1. It means that c by a is equals to 1, c is equals to a. This implies c is equals to a directly. Okay, you have to remember these 6 points. These are very much useful, extremely useful to you for solving the complicated and intricate problems. Thank you.